So right now I'm joined by Michelle Kuzio. She's product manager North America from Xylem, and Pedro Braun Streb. He's deputy sales manager for Europe at Gerhardt. So Michelle, who exactly is Xylem Lab Solutions?
Yeah. Xylem Lab Solutions is a um, piece under Xylem Inc. And we're an industry leading provider of lab equipment and instrumentation to offer unique solutions and solve lab problems for your lab. So we like to take on, overcome analytical challenges and that our customers might face in their analysis and provide analytical instrumentation to solve those problems.
Mhm. And you're the distributor for Gerhardt's products in North America. Could you elaborate on the nature of that relationship with Gerhardt?
Yes, so we are Gerhardt's North American exclusive distributing partner. We have developed this very strategic partnership so that it allows Xylem to offer a full range of instruments to for a variety of applications across many industries. And this collaboration has really ensured that we can deliver cutting edge technology across the full spectrum for our testing, for our customers' testing requirements.
Mhm.
So it's just a great workflow solution that we have with our distributing partnership with Gerhardt.
hmm So, Pedro, I guess when it comes to selecting an exclusive distributor, it's kind of like a marriage proposal. I mean, what do you look for in a partner, and what attracted you specifically to Xylem?
Yeah, first, of course, our very nice colleagues in the US, of course, like Michelle. And at the same part, I would say one thing which is really important for us is that we actually only work exclusively with only one partner for each country. And as I said, this sounds a little bit like a marriage. And for us, I think it's divided a little bit in two parts. First, we need a distributor that offers like a big solution for labs, like a variety of instruments that complement our own system to create really a good synergy, and so that we together can offer a very good solution to our end customers. And this Xylem has 100%, so there it's no problem. The second part is a little bit more if you're talking about people, because people actually offer the solutions to our end customers. So we need people on the other side that actually share the same values as we have here at Gerhardt. And the one would be, of course, having first a very high level of knowledge regarding the whole application, chemistry, and systems, of course. And the second part is really the commitment to the customers.
Mhm. Okay, so um, in terms of the value proposition, Michelle, that Gerhardt's products bring to your customers in the USA, could you possibly explain that?
Yeah, yeah, I think that the benefit that Gerhardt brings to our product line is kind of automated solutions that focus on sustainability, safety, quality, and especially throughput. So that we can help our customers increase samples through the analysis and just improve that piece.
Mhm. Okay, and let's come on to the products now. So, I mean, how long has Gerhardt been involved in the field of food analysis, and what were some of the initial protein analysis challenges that you had to address for the food industry, Pedro?
Well, Gerhard is really quite an old company, especially here in Germany. I think we're around, this year should be 108 years old. So we are in the fifth generation of the Familie Macke at the moment. So we go quite a way back, especially if we're talking about food analysis. But if we really look into the past, in the beginning, we were actually more of a company selling like basic laboratory goods, like you need some flask, you need some more basic stuff. And I think starting at 90/30, 90/40, Gerhard then had the idea to say, okay, is this really the business of the future? And then the idea was really to really offer what we already had in a, let's say, manual, classical way to automate this in some way. Of course, 50, 60 years ago, it wasn't quite easy because we didn't have the technology level that we have nowadays. But for example, in 1986, we developed the first Vapodest, which belongs to a part of the method of the Gerhardt method. And this was really the first automated steam distillation unit ever built and designed. So this is where we really started to focus on the automation of various parameters, starting from protein and starting for fat analysis, and for example, also the fiber analysis that we offer.
Mm-hmm. And when did Gerhardt as a company first recognize the potential of the alt proteins market, and how has your approach evolved in response to this growing, burgeoning field?
Well, I would have to say, for me personally, it wasn't that far ago because, of course, I am right now 5 years in the company. But even then, when I started, I already saw quite a lot of requests from customers. The main base or main source of information that we get is, of course, our key accounts, also the distribution partners. We try to be very, very close in this regard. So we hear a lot of informations. And at the same time, since we are talking with them and communicating all the time, which is really one of the key requirements that we have, we hear, of course, okay, we are having problems here because we're receiving new requirements for new raw materials. We have to be more sustainable. So there it really started to grow and grow bigger. And of course, if we continue there, we have European regulations here that we are also following and that are being shooted out by the government one after each other. And especially our partners come to us and say, okay, how do we encounter this challenge? And then we try to work together, especially in this field, of course, to offer the same quality of analysis that we did before.
Mm. And did you conduct any specific market research to understand the needs or challenges of this particular sector?
Market research, it's a very big and wide topic, of course. We have, of course, our marketing division trying to see with different kinds of analysis to see what is the... It starts with a simple Google AdWords campaign to see what are the people really searching for. And there you already get like a good picture what the people are searching for in the net, which is a part, of course, of such a market research. Then, of course, as I already mentioned, the key accounts where we work directly together, they have to have a solution for that even before it even arrives, because they are accredited labs, and to have accreditation you need to prove that you have a solution for this specific analysis already in hand. If not, you are not even allowed to do an analysis, and from there we really get our information.
Mm-hmm. So beyond protein analysis, what other areas of analysis does the company specialize in? You mentioned sort of fat analysis before, and moisture contents and fiber and stuff.
Exactly. I would say if we really focus on the range of solutions we offer, we are always 70% at least talking about food and feed industry. That means we're doing nitrogen analysis via Gerhardt is one of the possible solutions, or with the Dumas systems that we offer. So we offer two solutions more or less for the same parameter. Additionally, also belonging to the big five, the fat analysis of the product. So what gets on the label is also done with our systems. And if we change a little bit to feed stuff, we are talking about different kinds of fiber analysis that have to be done, for example, to adjust the food and feed for the cows so that they grow in a specific manner, how the people want them to. So this would be our, let's say, key areas where we work with,
Mm-hmm. And how are your protein analysis tools being used to support the development of alternative proteins? And Michelle, you could probably give us some examples from some of your clients in North America.
Yeah, I think that we use both protein methods for testing for insect protein has become one that's very forefront, as well as different kinds of mushrooms and proteins in mushrooms. Pedro may have some other additional ones that we're working collaboratively on from both areas of the world.
Exactly. Maybe from my part, I could say we work quite a lot with public institutes. So this makes around, especially in Germany, 40 to 50% of our business. That means also that we are in public research institutes, we are in private research institutes. A lot of universities here in Germany that are researching exactly such topics are working with our systems. And if we want to have, I think the two biggest examples at the moment, I would say the first one would be we're working together with the IFF in Brunswick here in Germany with a person called Patrick Sudwischer. He was the pioneer in researching how to analyze the chitin content in insects, for example, because insects, of course, in the future and in Asia, it's already started, is being used as an ingredient, as a raw material to increase the protein content in food and feed. The problem or the challenge that you have there is that not all the nitrogen that you are analyzing is actually protein you can somehow make out as a nutritional value for the body or for the livestock. That means you have somehow to analyze this parameter and subtract it to get the real value. And this was one of the bigger topics that we had right now. Yeah.
So with the fast acceleration in alternative proteins, that rapid innovation, how do your analyzers contribute to establishing standardized methods for measuring protein quality and functionality?
Well, that's a very good question, because standardized methods are, in the end, I think, the golden standard that we need to reach. At the moment, we are working together with different universities that actually analyze the same parameter, very similar with Keldal and Dumas, but use different methods to get there. All these methods, nevertheless, are always based actually on already standardized methods. So I would say it's not really reinventing the wheel, but to do an optimization of a specific method to reach the goal that we need here. And in the end, what will be the standard method, it's very, very difficult to access, I have to say.
And how do your analyzers ensure accurate protein content labeling for consumers? Transparency is quite a big thing for the consumers at the moment. So for them to make informed choices.
Well, this is actually a little bit difficult for us to assure, of course, because in the end, it's our end customers doing the analysis. But we have two building blocks which we try to contribute somehow. It is first a working system, so that you get actually a precise result with a good standard deviation, so that people know if they analyze with our systems, they got a good result. And the second building block is really to train these users of these systems to a degree that they have a knowledge and know what they are doing. Because if you have a good operator in front of a good system, you get good results, and that's how we try to do our part.
And can the analysis tools integrate with other data management systems?
Yes, of course. In the end, what we try to do with every redesign we did in the last 10 years, at least I would say, is actually one of the biggest parts is always digitalization, because all the laboratories nowadays works with a LIMS system, so an information management system. And the best thing you can do is actually connect to this already existing systems. As we all know, everyone can get tired in a day, especially, let's say, 5 o'clock. I want to go home. And what you need is that we have a process which is more or less foolproof. And that's what we try to do, to offer a solution and a process that is as automatic as possible, so that there are no possible room for errors. And transferring the data, of course, to an automatic system helps there.
Now, you offer systems both based on Keldal and Dumas. So could you explain the underlying chemical principles behind both of those methods for protein analysis?
Yeah, well, maybe I give the word to Michelle, because she's, of course, our product manager in the US.
Yeah, I think it's the best way is to say it's, different principles measuring nitrogen to determine protein. So the Keldal method measures the nitrogen content by digesting the sample with sulfuric acid and converting that to nitrogen. To ammonium sulfate, and then that's distilled and titrated to get a measurement. The Dumas method involves actually combusting or kind of burning up the sample at very, very high temperatures to convert the nitrogen to nitrogen gas, which then is measured a little bit differently with a thermal conductivity detector. And so both of them measure protein at very low levels and kind of solve the same problem.
And how do they both compare, Michelle, in terms of accuracy and precision in protein content determination?
Oh, both of them are very, I might defer to Pedro, but all the results I've ever seen are solid, high precision, low standard deviations, and very low levels of nitrogen. On the Dumas method, we're measuring 0.003 nitrogen absolute, and that is a very low level in the industry. Pedro, do you have anything you might want to comment on there?
No, it's totally right. The thing is, it's always to see what is the best solution for the customer, because if you really look only at the first numbers, like the detection limit, you see the Dumas can go actually lower than a Kjeldahl analysis can. But the introduction of the amount of sample at the start of the process is that you can weigh in with the Kjeldahl method in such a system 20, 30 times as much as you can do in the Dumas system. So even if the precision, or say the lowest limit, is 10 times lower, if you can weigh in 20 to 30 times more, you get around to a very similar precision level. So it really is the requirement of the customer is important, and the sample type he is using actually.
Mm-hmm. And do these methods account for non-protein nitrogen sources that might be present in the sample?
Yes and no. It's a very good question, because NPN is more like a parameter being analyzed normally in milk products. There, we were talking already about parts of a protein that are maybe not used in the body or not digested. Chitin, for example, in insects would be an example, but also in other products, we can have nitrogen sources which have really nothing to do with protein content as we are analyzing it normally. So in both methods, you analyze directly the NPN content. The problem is you cannot directly separate them. That's why you have to do an additional analysis with the same sample, where you get your NPN content, and then you have the full content minus the NPN. Then you know, of course, you can calculate your value. Yes.
So which method is better suited for analyzing content in a variety of sample types, such as solid foods or liquids, processed materials?
This is really difficult, because it's really dependent.
There's other questions, right? So, a lab that has very high throughput might have very good success using the Dumas method, because that method can take liquid or solid samples. But there's a lot of additional questions, I think, that have to be answered to provide the best solution for the customer, which is why we are very protein analysis, and we're very solid on both methods and can guide the customer to the best solution, not just the one that we have, because we offer both of them.
And in terms of sample size requirements, what's typical for each method, and how long does each method typically take to complete an analysis? It's another important factor.
Yeah. Pedro can probably comment on the volume of sample that you use. For the Dumas method is much smaller sample size, but the Dumas method provides results in 3 to 5 minutes, while the Kjeldahl method is several hours. So you might have the better on the exact specifics, but the Dumas method is extraordinarily faster.
Yeah, there I would, of course, go with Michelle. If we're talking about the Dumas method, we are talking about amounts between, let's say, theoretically 0 milligrams to 500 milligrams, or depending on the system, also a little bit bigger. But the reason is, of course, since we have such a low of a detection limit, we don't really need to weigh in 1, 2, 3, 4 grams. At the same time, with Kjeldahl, there you can do anything between 0 and probably even 50 grams if your tube is big enough. So, of course, with such a high sample input, the variety of samples could be a little bit bigger with Gerhardt. If we're talking about all sample types in the world, I would probably go for more to the Gerhardt side, but that doesn't mean you cannot analyze it in the Dumas with a proper process.
Mm-hmm. So when we come to consider things like reagents and consumables and instrument type operation costs, which of those methods is generally more cost effective per analysis?
Well, in this regard, it's actually the Dumas method. So the method that is faster, because there you need your gas installation, of course, this should be there, but the rest is really more or less minimal costs in comparison with Gerhardt. Gerhardt is a very old, also universal method, but at the same time you are using hazardous chemicals, and at the same time they have to go somewhere. Normally the river isn't a good solution, so you somehow have to pay money to someone that specializes actually in this regard, and normally this costs quite a lot, and you have to somehow put a value on this, and this is really where we make I think the biggest difference. Yeah.
Mm-hmm. And in terms of the technical expertise required to operate these systems, is there a big difference between both?
Michelle, what would you say?
I would say that once we have had the opportunity to train our customers and teach them about the instruments, that I would say that there is not. So Pedro commented on the beginning, but they're thinking of all the things to keep things simple, to keep things safe, to let things run when you're not right in front of it. And so I think all of those tools are in both systems for that they're probably equal.
Yeah. And are there automated versions of both methods? And how do they compare in terms of efficiency and user-friendliness?
Yes, there are automated versions. And, we have full range on the Keldol where we can have, a sample changer. The Keldatherm is our system that does the digestion. Then you move that to the Vapidest. We have a system you can fit a bunch of tubes in and it'll automatically feed into the system. And the Dumas method, the Dumas holds about 100 samples at a time. I can't remember. Pedro can comment on how many you can get in.
Yeah, exactly as Michel explained, we have 100 positions. For example, in a Dumas system with Gerhardt, normally you have 20 positions. Yeah. And of course, if a Gerhardt method takes 2.5 hours, we're talking about 20 samples at the same time, while in the Dumas, we're measuring sequentially one after each other, and it takes 5 minutes. If we talk about time efficiency, of course, 100% Dumas is faster. It can analyze more samples in a day. If, for example, for a customer, he has a lot of sample types and variety there, it could be that efficiency is for him to have one system that can handle really every kind of sample without him investing a lot of time to validate really every sample type. So I would say, but I will still probably go to the Dumas system. Yeah.
When it comes to novel foods, is one method, Gerhardt or Dumas, generally preferred or required by the regulatory bodies, the agencies?
I would say at the moment, no. The thing is, novel foods, in my opinion, isn't really new, but when do such regulations even start? It's normally when the productions are very, very big. We're talking about 100 tons, 200 tons, and then the analysis precision gets really vital. And in this regard, we are very much, I would say, in the beginning of a very good path. So there are some starting regulations there, and it's not really going to say, okay, analyze with Dumas or with Gerhardt. You can do both. But I guess in the future, if I would have to bet, it would be probably going to the direction of Dumas again. Yeah.
Mm-hmm. We'll talk about some of the. Sorry, Michelle, go on.
I'm sorry. I would agree with Pedro. So throughput with the Dumas method, plus it just offers, advantages in terms of safety, sustainability. You don't have to have hood space. You can just get, really have high throughput.
Mm-hmm. We're going to come on to some of those industry challenges now. So how do complex food matrices such as, I don't know, high fat or carbohydrate content interfere with accurate protein analysis? And what are the current strategies to mitigate some of those effects?
Well, of course, if you're analyzing a raw material, it's quite a lot easier in comparison to a very complex product. I would say the challenge is to find one optimized method because, for example, if we take the method Dumas, we have a catalytic amount of oxygen we use for combustion. This is the amount is based, for example, as you said, on probably the fat content, how long is my carbon chain. So there are various factors that impact that. But if you found one time like an optimized method, this normally works for all kinds of similar products. So it's just finding the first time this optimized method. And of course, in this regard, Xylem and Gerhardt work together with the end customers. Normally, we already have a big application library with the ready done solutions. And if they don't do the job, we still have like 10, 15, 20 people working in the background, optimizing methods and working together with the customers to actually reach this optimized efficiency method. Yeah.
Mm-hmm. With the diversification of protein sources, I mean, you've talked about insects already, but algae, are there any limitations in current analysis methods to accurately quantify and characterize these proteins?
I would say no, of course. If we're talking about here, it depends really how we define the protein content of this kinds of product. Because at the moment, if we talk about official regulations, there are really known that are describing maybe to separate here the NPN content of a sample, even if you introduce this actually in food and feed. So we started this as a pioneer work really with the IFF in Brunswick and with Patrick Sudwischer. So at the moment, no challenge at all, because whatever you analyze normally with Kiel or Dumas is the protein value everyone is stating and working with. But in the future, I'm pretty sure the challenges will arrive, and that's why we're already working right now together with such institutes to offer directly a solution to separate and get really the real protein value for the customer.
Mm-hmm. As R&D efforts intensify in protein science, so what are the bottlenecks in current methods for high throughput protein analysis?
Bottlenecks is a very difficult word, of course, a big word. I would say it's to get really the system so automated that a person only has to press a button. That's the goal, I guess, for every system, every machine, because the more automated it is, the less error prone it will be. And your systematic error of your values, the standard deviation go down and down. So I would say this is really the bottleneck, because you optimize more and more. At the same time, you have to be sustainable. And of course, you want to keep at the same time also speed up the analysis, because if you have a big tanker with 100 tons of oil seeds waiting at the harbor, this guy at the boat doesn't really want to wait 1.5 days to receive it's okay or not to unload his cargo. So in this regard, it's really to receive as fast as possible, but still keeping the minimum, or better say the optimum precision there to make the good choices.
Some protein analysis methods, they require harsh chemicals or extensive sample preparation stages. Are there ways to develop more sustainable and less labor-intensive preparation techniques?
I would say preparation-wise, most sample preparations are quite the same actually, because if you go into a Dumas method, which is of course the more efficient and also the more sustainable method, it's exactly the same as you go into a Kjeldahl system, because the better you work there, the better your result will be in the end. So I would say there isn't really a big difference. No, I wouldn't say there isn't really a big difference, no.
Okay, well, look, we covered some of the industry challenges. We covered that comparison of Kjeldahl versus Dumas, and we've also covered the relationship between Gerhardt and also Xylem. So I've got one final question for you both. I mean, you live in this sort of lab world, so I'm just wondering, if you look out to the world of alternative proteins, what particularly excites you about what you're seeing out there at the moment?
Oh, I would give to Michelle first.
Yeah, I think what excites me is that I think it's going to be the wave of the I think it's the future, and I love to be a part of things that are what the future holds.
Mm-hmm. Yeah, Pedro?
Well, for me, I would say what I find really quite interesting is that normally a lot of development or innovation is actually driven by regulations. No? So this is a very typical thing, especially in analytic chemistry. But at the moment, when you asked me for where did we get this information, it was not from any regulation, but because even the companies are already starting to really think about, okay, how can we as efficient and as sustainable as possible by themselves, and having really a lot of different pilot projects that we of course hear and talk about with them. So this is for me really exciting to see, okay, there is something happening in the background, because I would say worldwide there are a lot of bad news, but at the same time, we have also a lot of good news, especially in this regard, to get more sustainable, to improve livestock, to improve vegetables growth, to produce new kinds of products which are a lot more sustainable than the one in the past. So I would say it's really cool to be a part of this. Yeah.
Well, Pedro, Michelle, thank you very much. You've explained the technology very well for me. I'm not the most intelligent of people, but I think I even took some of that on board. So yeah, lovely to have you with us, and hope to see you soon.
Perfect. Thank you. Thanks for your time today.